Okay, so today we are continuing with our tour of pandas. And just to review, I'm going to click on lessons here on the GitHub page. Last time we did lesson 11, and I made some minor edits after class last time just to clarify a few things that came up as we went through the lesson. And so we discussed series and data frames. Data frames are the main data structure in pandas. These are like tables, and series are typically we think of these as the columns of a data frame, but they can be rows also. If you pull out a row, that's a series. It's like an array, but it has additional features beyond what a NumPy array has. We looked at the index and columns, which are the names that we use for the rows and the columns respectively. We looked at data types and getting info and describing a data frame. We read CSV files, and we also read Excel files, and then we wrote two in CSV and Excel files. We looked at the head and the tail, so these are the beginning and the end of a data frame. It's useful to just look at the first few rows of a data frame. Often that's enough to be able to tell if what you were doing worked. You don't have to look at the whole thing. We did some indexing, and we had a little, we covered a few little other things like transposing and converting to datetime objects. So today, we're going to do lesson 12. And this is we're going to cover a little bit more advanced topics in pandas. So concatenating and appending things to data frames, or concatenating two data frames together, or merging, which is a little more advanced, where you're actually choosing how to merge two data frames. And we'll cover stacking and unstacking, which have some cool ways of sort of reformatting data frames. We'll cover some functions, and then how to sort data frames also. So we're going to go to raw format, which will show the raw JSON format of the file. Copy that file, and then go to our terminal. We're going to navigate to our course folder for the working directory for our lessons, and do curl-o, the name of the file. Download that, and then source activate the environment, and then launch it, Jupyter Notebook. Okay. I'm going to just toggle this head bar. And last thing is we'll go to all output and clear, so that we're all on the same page. Okay, everybody follow along. You should be experts at this by now. Okay, so first thing we'll do is import pandas, and we'll import NumPy as well. Okay, so first thing is merging, joining, and concatenating data frames. This is the major thing we'll cover today. What I've done for this lesson is I've copied some of the documentation from pandas so that you can have a reference right here in the notebook of what these functions do. So there are 4 sort of functions that we will cover today that concern merging and concatenating. So concatenating is just as we see it in other examples in computer science, where we take two things and we just kind of sandwich them together. They just, one after the other, They can either be concatenated. If you think of two tables, you can either have one table and another table, and they just go on top of each other, or they can go next to each other, and you have that ability to choose how you concatenate them. You can think of different examples where it might be useful to do this, to have data frames that are maybe very similar or identical in their structure, but they have different data, and you want to concatenate them. So if you're combining two data frames, if you're concatenating two data frames, you can use the function PD or pandas. Remember, PD is what we imported our pandas as. So you can either provide a list of data frames and concatenate them that way. In fact, you can concatenate more than two. Or if you have a data frame already, that data frame has a method to append a second data frame to it. So this is this feature of this object-oriented language Python, which is that you have functions that are specific, that you call from pandas. So pandas has this function concat, and you give it two things. Or if you already have a data frame object, that has its own methods, including, okay, I want to take this data frame and append something else to it. So you have two ways to do basically the same thing. The same is true for merging. So with merging, you can merge two data frames, and typically you'll specify how you want to merge, because this is a little more sophisticated. So with merging, let's say you have two data frames that they have the same type of indexes. So the labels for each row are similar. They're from the same style, but maybe they're not completely overlapping. Maybe you have one data frame that has 100 rows and another one only has 50, and the 50 are a subset of the 100, and then you also have different columns in both. So you want to say combine them and add the columns of one to the columns of the first. And so you can use a merge kind of operation to merge, say, using those indexes as the keys, as the thing that you're merging on. So you can either, just like with concatenating, you can merge using a function, a pandas function called merge, and you pass two data frames. And for merging, you can only merge two, because the logic gets too complicated if you have more than two. But there's also an analogous function called join, where you take one data frame and join a second one to it. So first, we're going to do concat. So there's the full documentation is shown here, but the simplest form is just to pass a list or a dictionary of series, data frame, or panel objects. Typically, it would be a list of data frames. And then you can specify the axis. So typically it would be 0 or 1, and it's a question of whether those data frames are concatenated side by side or on top of each other. There's to be honest, I always forget and I just test it. We'll see in a minute. Yeah, it's I believe, I don't even want to speculate, because I'd always just trial and error. It's not intuitive to me which is which, so I've never memorized it. So let's just dig in, and we can refer back to this if we need to. So what we're going to do is just create 3 data frames that have very simple values. So they're all strings, but the nice thing is that they're going to indicate the position. So we have column A, and it has values A0, A1, A2, A3, etc. So this will allow us to see what's going on. So if we just display these data frames, you can see we have the values in the cells correspond to their column and row labels, their indexes and their columns. All right, so we should be here. So we're going to create a list of data frames, and we're going to then concatenate that list of data frames and save it as this thing called result, and then we will display the value of result. So we can see that we have now concatenated them on top of each other. So to answer your question, the default is axis equals 0, so that will concatenate things on top of each other. And this actually, if you think about it, makes sense. If you have multiple data frames that have the same, if they're like the same type, same kind of data frame, you might expect they'd have the same columns but different rows, right? Rows are sort of like the columns are typically the information you'd have for every sample or everything, and then the rows would be added to each other. So like you had one day of data, and then you had a second day of data, and a third day. You'd concatenate them by rows, right? Keeping the same column. So that's what the default behavior is. There's this option called keys, which constructs a hierarchical index using those keys as the outermost level. I don't use this very often, but it's available to you, so you can add. Basically, it's a secondary index, and we'll cover how that works actually. So I think we want loc. Yeah. So that IX, you'll see that message in red that we got said that IX is deprecated in the newer version of Python, or pandas rather, so we can change that to loc, and I'll update this on the GitHub page. So what I'd recommend is at the end of the quarter, you can download all the notebooks from GitHub and have the clean version on your computer, and you can always go to the GitHub page and get the gold standard or the latest greatest version. So this is just a way to use a hierarchical index. So we'll see this axis thing in a minute. So here is a fourth data frame that has some different indexes and different column names. So if we want to concatenate these two data frames, we can see what happens. So we notice they have some overlapping indexes. So 2 and 3 are indexes found in both data frames, and B and D are columns found in both data frames. So when we concatenate them, pandas will try to match up the row and the column names so that we don't get unexpected behavior, right? You want to preserve those if possible. However, you can see that in fact it only preserves the column name. So we have indexes that are repeated here. And the same is true for if we change the axis. So now we're concatenating these things side by side. So the row labels are non-redundant, but we have some redundant column names because we've concatenated these things left and right. So this would be a case where, depending on what kind of data you're working with, you might want to do more of a merge operation than a concatenate, because you're going to have, if these column names are really meaningful, you're going to get different sort of behavior. So we can add a secondary argument, which is how we're going to do the join. So if we go back up to here, join is how to handle indexes on the other axis. So the other axis meaning you specified which axis you want to concatenate along, and those will be sort of handled. But then you have this other axis, like say the rows that that might be repeated. So how do you want to handle those indexes? You can either get the union or the intersection. So the union, the outer is the default behavior. But if we do the inner, because we have, so we'll still get repeated labels, but we're gonna, anytime there are nan values, it will just remove those rows. So here we had row 0 and 1 and 6 and 7 that had missing values, and so the only when we specify join equals inner, we only get those 2 rows that that have values for all columns. Now, if we want to ignore indexes and not worry about, so in this case where we had these 2 and 3 were repeated, and this is kind of annoying, but let's say we don't really, these row labels aren't meaningful, they're just relics of the previous data frame. And when you see these indexes from 0 through the end of your data frame, those are typically automatically assigned. So you maybe don't need those. So you can reset them or ignore them. So when you do the concatenation, you can set ignore index equals true. And what this will do is it'll re-index the rows for you. So now you don't have any repeats. Just a couple more examples here. So we have here just 3 series we can concatenate. So we created these series. This one has a name. The other 2 are just default. And when we concatenate them side by side, we get a data frame with the column names corresponding to the names of the series. And similarly, we can take those series and we can rename them using this this keys function. So because they're series and not data frames, that hierarchical index, we're not creating another index. We're just using, they're just being created as the names of the columns. Any questions on what we've got so far?